Welcome to a lesson with Dr. Powell. Let's talk about how a matrix action on a vector can be thought of as a scalar action on a vector. For instance, if x thought of as a matrix here, we're also thought of as a scalar. When we rescale this vector, we just simply multiply x to the components and we get this. This right here is a representation of the matrix X acting on this vector. So we can write it like this, x, x, 0. But we also know if we plug this vector into x thought of as a function, this simply means to, with the column interpretation, so multiplication on the right here, this simply means just to add these two columns together and we get this. So this tells us something. This tells us that the vector 1, 1, 1 is also representable as xx0. Now, this does not mean that the entry 1 is equal to x or that 1 is equal to 0. No, this simply just means that this vector itself has two different representations where we're allowing x to be like a scalar in the entries here. Okay, so let's take a look at another example. Let's take a vector right here, x, 2x plus 1, x squared minus 1 as our entries. Now we can go through and kind of dissect this to see what does this really mean as a solid vector. In fact, it's going to be this one. How is that? This is another representation of this vector. We can kind of split it up a little bit. See this x in the first component? That's like saying x times this guy, 1, 0, 0, plus and 2x times a middle guy here, plus 1 times a middle guy here, plus x squared times that, minus 1 times that. I've just kind of split this apart. If you added these together, you definitely would get this, right? But I split this apart so we can kind of think of it this way. So x times this vector, all right, this just means to pick out the first column. Got it. Then 2x times that vector. So x times this vector means to pick out the middle column of this, which happens to be the same thing. So we started with 0, 1, 0, and then we just double it. We rescale it by that 2. So 0, 2, 0. This right here is just 1 times that vector. So 0, 1, 0. X squared times this. So first, we run this vector into x. What do we get out? So this is 0, 0, 1, which just picks up the last column. Negative 1, 1, 0. And what we do then is we take that and we put it into x again. So we're just putting this column into the matrix function x, which simply means take the first column, make it negative, and then add that to the second column. So you end up getting negative 1, 1, negative 1. And then over here, negative 1 times that is just that. Then you just add and subtract component-wise to get this. Important to notice that x is not equal to 0. 2x plus 1 is not equal to 4. X squared minus 1 is not equal to negative 1. This is simply just an equality of representations, with x being thought of as a scalar in your entries and here. But it does not mean that the entries are equal across. It's just a representation of vectors. Thanks for watching.